Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, peace be upon you. First of all, let's give praise and gratitude to God the Almighty, Allah Subhanahu wa Ta'ala, who has given us mercies and blessings so we can be present here in perfect health amid the current COVID-19 pandemic. My name is Gama Harta, your moderator. I would like to welcome all of you on behalf of the committee to this international webinar on green innovation. We are so delighted for having all of you today. Dear all participants, this webinar is held by Faculty of Engineering, Pancasila University, as the second occasion of its 5-webinar series. This webinar will focus on trend in green technology innovations. We are sure that this topic is highly important for all of us, as we know that the attention toward green innovation as well as sustainability has been growing recently since our beloved Earth or environment, either the air, land, or sea, has become more and more suffering day by day, all around the globe, as a result of our profit-oriented actions, which has somehow neglected the environment. In this connection, we all should show our responsibility, whatsoever our role in the society, especially we as academia, to improve the quality of our environment by doing some innovations, for sure, to overcome such the issue. Well, at this time, we would like to have a presentation from our distinguished speaker, Professor Ralph Foster. Professor Ralph Foster is currently the head of Production Engineering Laboratory in Boyd Hogeschool voor Techniek, also known as Boyd University of Applied Sciences in Berlin, Germany. He is also visiting professor for several universities such as Pancasila University itself, Institute of National Science and Technology, and German Chinese University of Hefei, China. His research fields include electro-discharge machining, electrochemical machining, micro-machining such as EDM and ECM, machining ceramics and glass, friction welding of bamboo and wood. Well, the latter research field is for sure closely related to our topic today. Professor Foster will deliver a presentation entitled Trends in Research of Sustainable Materials. He will highlight his research in using some alternative materials, especially the bamboo, and in application of joining technology. This effort is part of our responsibility to answer the Green Innovation Challenge. Okay, ladies and gentlemen, before we begin the presentation, I would like to inform you that this session will be divided into 2 sections, the presentation section and the question and answer section. For the Q&A section, you are allowed to ask for questions using the chat feature. So during the presentation, you can write down your questions there. And to get me easier to find your question, please start your question with a hashtag symbol, followed by the capital letter Q, that means question. Okay? And also, I would like also to inform that the presence link will be sent via chat room during the session. So don't forget to fill it out. And since the certificate link will also be sent via chat room soon after the closing of the webinar, therefore I hope you don't leave this webinar first before filling out the presence form and downloading your own certificate. Well, without further ado, I would like to welcome Professor Ralph Forster to deliver his presentation for the next 45 minutes. All right, Prof. Please.
All right. I will share my screen. I hope, you can see my screen and you will hear me very well.
Okay, good. Yes, we can see it clearly, Prof.
Okay, that's great. Okay, selamat siang, very warm welcome from Berlin. Our weather is a little bit cloudy, but no rain, and we are happy that we don't have any coronaviruses. I hope the same of all my auditorium. I hope you will stay healthy in future, you and your families. And now I will start my presentation about our last trends in research of sustainable materials. I guess a lot of you know the first overview slides about our topics, about the application of friction welding, different sandwich materials, about our research in bamboo, wood and sustainable materials. As you know, the world population is growing very strong. We see in Africa and Asia a lot of peoples. All these people want share the same living standard like the Europeans. On the one hand, on the other hand, we try to protect our nature and the environment. Nobody of us can live without nature. Everybody wants to increase the living standard. We need to reduce the pollution, the waste, and we must protect our nature and the environment. If we can use reusable materials, sustainable materials, we must collect a lot of knowledge about the material properties, about the behavior during the life cycle of our devices, of our products. We try to developed compound materials, and we must collect some knowledge and some experience about the interaction of different materials when we try to use the advantages of new developed materials, and we have to increase our knowledge and our skills, of course. So we need other construction materials. We need some alternative building materials, as you know, in the sand for mixing concrete to building beton is decreasing. The prices for this material is increasing very fast. One of our alternatives are wood. In Europe, well known as a material for houses, for devices, and so on. Everybody knows this. In Asia, there's well-known bamboo as a traditional material with very interesting material properties. But we need some new technologies for use bamboo, like joining technologies and so on. And we have investigated in the last year the friction welding process on bamboo and wood too. and I will tell you something about our results and something about our ideas of new materials. Yes, all of you know bamboo much more better than the Europeans. The structure of bamboo is similar to wood, and the basic properties are also similar, but bamboo is a member of the grass family. It's not a wood, it's a grass. And there is a hard outside and a soft inside. It's very tear resistant fiber stands, and most bamboos are divided by knots, and the tensile strength of the bamboo grass reach values up to 14 kilonewton per square centimeters. The main content of bamboo is cellulose and lignin. This is also similar to wood. Very interesting and very important for the connection of bamboo with the friction welding process is the content of lignin. The content height of lignin in the bamboo plant is similar to wood, and that's why we can use the experience in friction welding of bamboo also for the friction welding of wood. So here are different pictures, cross-section of bamboo, of different bamboo types. You know, there are a lot of different types and a lot of variety of bamboo. Here are the knots. It's a cross-section of a bamboo stem with the knots and the hard outside and the empty inside with very stiff knots. So, what are other sustainable, very interesting biomaterials like coconut husk, banana stem, and so on, banana ropes, palm tree fibers? Those are biofibers. These are very interesting for the next step for outside material of sandwich materials, lightweight sandwich materials, like hemp fibers, like linen fibers, and so on. There are a lot of ideas and opportunities to use such materials from a bamboo system. We have some properties of such sustainable materials like linen, also for hemp. These are very often used in Germany or in Europe for ropes, for clothes, for pillows, and so on. But there are no so many applications in with a technical background, with an industrial background. But the advantage of the biomaterials are they don't have, after using, with the end of using, no hazardous waste. They have no influence of the, also no negative influence of the environment, and we can use it independent of our Earth. So, but we don't have such standard values. We don't know the properties of the Asian biomaterial, like banana trees, like coconut fibers, and so on. And that's why we have to do a lot of research with these materials. The last year was the year of Corona, and we don't have had the chance to exchange our knowledge. We don't have the chance to travel to Indonesia to get some more informations about the Asian fibers and so on, but I guess in the next year we can cooperate together and we can try to find out more properties and can increase our research in this topic. So what we have done in the last year, we have installed a cooperation with a niche company. They are a developer of special material testing machines. We have different chambers. We can adjust the chamber temperature between minus 160 degrees up to 500 plus 500 degrees. We can measure different deformations of this. We can adjust the moisture and so on, and we can collect a lot of data. Depends on the temperature, depends on the water content of our material, and so we can do a lot for collecting the basic knowledge about the behavior of our biomaterials for new applications. Here are some tests which we have carried out with hemp fiber. We have a constant temperature of 24 degrees and the constant humidity of 20%, and with a time sweep which increased stepwise the humidity, and the temperature sweeps between 20 and 18 degrees at two constant humidity values of 13% humidity and 60% humidity. So that we can collect first data with hemp fibers. Actually, we are trying to install new clamping systems for measuring really single fibers, very thin single fibers of our material, and we have seen how the behavior is changing during the time. Here are also some results with different humidity values and what happens with the stiffness of our material. Here are some other results about the tension. Depends on the this different static loads and dynamic loads at a fixed temperature and with a continuously increasing humidity. Oh, here are some other results. These are also results from one single hemp fiber, but for the future we must collect much more values for different materials and with different testing environmental conditions. Yeah, some others. What is a main problem of our research are the connection. Here are some traditional connection systems of bamboo and wood. We can join this with some ropes, with seals. We have metallic joinings. We can connect it with some bands and so on, like fibers, like thicker fibers and so on. But the demands for joining technologies are this connection should be free of chemical glue. It should be sustainable. We want have hazardous waste, and the connection should be reproducible. Here can you see the traditional friction welding process of a metallic shaft. As you can see, at the first step we have two metallic cylinders. Then one of our cylinders is fixed, and the other part of our sample is turning, and with a high pressure force, temperature is increasing. We can reach the melting point, and we can get a very stiff connection between these two parts. After turning, we don't see any differences in our surface, and we have a very nice cylinder, a very nice shaft. This is a standard technology for friction welding. Yes, it is. As you know, the Germans like it to make tables, to make standards and so on, and also the friction welding process has own standard. We have the welding through movement. This means there is no external heat. There is no flame, no plasma, nothing. We have an ultrasonic welding. We have some sonotrodes in this ultrasonic welding. This is very often used at the electronic industry, at the semiconductor industry, like ball bonding, like ultrasonic bonding, if you want to connect the very thin wire of integrated circuits with the outside plating. This ultrasonic welding is used, I guess, in 99% of all connection processes, joining process in the semiconductor industry, and we have also an ultrasonic welding process in the packaging system. If we cover some very sensible devices, electronic devices with some sheets of plastics and so on, the connection is very often, for the connection process is very often used also an ultrasonic welding process with an sonotrode. Then on the other side we have a friction welding process. This means we are using the friction between two parts for initiation of a very high temperature, for initiation in high energy content, and then we have an vibration friction welding. That means that our pieces are moving against each other, and then we can, if you take your hands and put your hands together, then you can feeling also the thermal behavior of the friction, and this thermal energy will be used for the heating and warming of the surface, and then we get also a stable connection of two pieces. Like the linear welding process, that means we have only a linear movement, or the angle welding process, that means we are turning the both parts against each other, and then we have the same effect. And our topic are the rotational friction welding process. That means one of our pieces is fixed and the other is turned. There are any questions? Hello? If there are any questions, you can ask me.
I think it was only a noise.
Okay, it was only noise. Oh, I'm so sorry. Okay, and this is what we are doing. We have one fixed part and the other rotated part with a pressure forced for the connection. Here, these are some cross section of linear friction welding of wood. This is real beech wood, and here can you see also the debris outside of our welded zone, the thermal influence zone, and there's also an friction welding process for a cylindrical connection joint in one borehole. What can we see when we have a cross section and look inside of our friction welding zone? We have a compacted cell structure on the top, and down we have also a compacted cell structure, and in the middle, where is our connection, we have pyrolyzed mass. That means it's a mixture of carbon, a mixture of lignin, which is used as a natural glue, something like that. After high temperature without burning, we have natural glue, a sustainable glue, which is used for the connection of our different wood or bamboo types. Some advantages of friction welding of wood and bamboo are the connection can be established quickly within a few seconds. We don't use some additives. We can combine different wood and different bamboo materials. We can adapt different type of wood, a different type of bamboo for the combination of different behavior and for different applications. We don't have any curing times compared to some used glues. And the complete product is only made of wood or of bamboo without any additional materials, and that's why is it really easy to recycle. We can put it on the earth and wait some years, and we have also earth, or we can take it to a fire and we can eat some zati or whatever. We can use it like standard wood materials, like standard wood products, without any influence of our environment. So, 3 years ago, I have, or 2 years ago, I have shown you our first initial test. 2018, we tested pine and beech with our standard turning machine. I hope you will remember what we have done. I will show you our first videos about this. I hope you can see the video.
Yes, we can see, Prof.
Okay, that's great. That was our first test equipment. It's a standard turning machine. It was very easy to use. It was a fast start, but the first steps was really successful. So this was wood video. Here is a sample, suture same process with bamboo in it's a lace. We need a special clamping system for the bamboo material, but it works very well. So, and as you know, it works also in Indonesia. We carried out the same similar test at the Pancasila University with original bamboo from Indonesia, and as you can see, it works in Indonesia very well too. And we have get the same results, and of course in Indonesia we have bamboo with a thicker diameter, and then we have also a higher stiffness and so on. And as you can see, it worked in Indonesia in the same way like in Germany. That's great. Huh? That was our first steps 2 years ago, and we carried out a lot of tests about the welding time, the welding pressure, the path length, the speed rate, and so on. 3-point bending test, you know all this, but the big advantage is I get the funding from the German government together with an industrial company to build up a special adapted friction welding machine, especially for wood and bamboo too. Here's a short look inside the machine. This is our clamping system for the rotational part. Here is the clamping system for the fixed part. Yes, here is a different view. This is our turning part, and here this is a fixed part of our product, and then we can combine this, and we have make a lot of tests, as you can see here in the video. This very hairy arm is my arm. And we can adjust the pressure time. The system stops very fast. We can adjust different after pressing times, and so on. We can adjust the rotational speed and so on. And as you can see, it's stiff and hard. Of course, not each test works well. Here's one of our failure videos. Not each project in Germany is successful project, and not each test is a successful test. As you can see, nothing happens. Huh? No smoke, no temperature. There's nothing. The problem is the friction on this both parts of the clamping system was not enough, and that's why we put it through the clamping system. Okay, these are our new equipment. It's we get it 1 year. 1 year ago, that was finished, and since this time we carried out a lot of tests and a lot of new. We create a lot of new results, and we have increased our knowledge about the process. This is our testing equipment for the tensile strength test. Yes, it's a standard system of the Zwickroll company. Here are some results of the tensile strengths of pine. Here the tensile strengths, and here are our different sample with different test parameters. Yes, and as you can see, we have an strong influence of the testing parameters. Of course, we could identify the best parameters for the pine and also for beech wood. What is a very interesting result, we have different results depends of the thickness of the width of the annual ring of wood. This is not independent from the structure of the wood. That's a very interesting result that we have an influence of the inner structure depend on the ring width in the wood structure. So here can you see? Here is the pine, and as you can see, these are the different wood annual rings at the wood structure, and this is also like a gluing connection, like a additional joining connection. And at the pine, it's in most of all samples, it's a problem, it's the influence of the pine wood. When we have a look to the beech wood, we don't see such behavior. And it's a really different difference of the wood material, and as you can see, the tensile strength of pine is 2 times higher than of beech. What was another effect? We have tried to test the hardness of the single annual rings, and that was really interesting. We have an early wood. This is much more softer than the late wood, and you can imagine that we have different friction properties, different pressure forces on this material. This is a piece of one natural growth up beech wood with such really different hardness values. This is hardness of Brunel, and here are also the diameters of the beech compared to the early wood and to the late wood. In Germany, sometimes it's called also summer and winter wood. That's, I don't know, maybe there are similar similar behavior in Asia, Indonesia, but I'm not sure about this. But this is really interesting result that we have seen such an influence. So okay, here are some pictures with an thermography camera. We need temperature in the range of 300 degrees, and we could see this with an infrared camera. And we have also a computer tomography system, and here can you see the welding area. And here is are the different wood types, the different wood structures. These are similar of the different density of the annual rings in the structure, and that's why we can find a different behavior. As you can see, this is also in a picture, and you can see the borehole inside in the middle of our test equipment, and how it works and how it connects in this welding zone area. Here, similar different sample. It's a sample 3, and here are similar welding zones. It's comparable to the other pictures, but the structure of the ground material is a little bit different. Okay, what we done too. We compared the friction, the tensile strength, which we reach with an friction welding. The average value was 3.3 megapascal. And when we are using different glues like Ponal-X press after 8 minutes, after 13 hours, Ponal water glue, and also Otto Color. These are German trade names. I guess I brought 1 year ago similar glues to puncture seal, and you can use this glue too, so that we have with a friction welding process not the same values, but 50% of this values without any additional chemicals, without any hazard materials, and this is a value which is acceptable for the wood industry, for the skilled workers and so on, and our cooperation partner says, okay, that's fine, we can work with such a process. Okay, I guess my time is over. I have 40 sheets more. In my opinion, I should prepare a lecture for 2 hours, but I guess your plannings was a little bit different. We can interrupt here, and you can ask me some questions. We can discuss about the results, whatever you want. It's your decision.
Okay. Okay, thank you so much, Prof. Foster, for your informative and interesting presentation that you have shared with all of us. I think there are a lot of things that we can highlight here related to our theme, the green innovation. We can see that as our environmental, the environmental degradation progresses, the replacement of materials must be done toward more sustainable or eco-friendly materials such as wood, bamboo, or other biomaterials. As like what you already shared with all of us, there are a lot of biomaterials that we can select or we can use as the substitutes for dominant material like metal, for example. There are a lot of materials like coconut husk or banana stem, hemp fibers, linen fibers, etc. All of them can reduce waste and pollution. And we can find other highlighted information from professor's presentation. The material properties as like bamboo, as described, has supported our view, that there are a lot of alternatives that can we exploit, to support our view regarding the green innovation. And there is also some related technology technologies that are available, yeah, to be applied for such the purpose.